Good afternoon, students. Um, Welcome to this channel. We have been on simple harmonic motion series. We have shot the first and second videos, so this is the third one in the series. So let me advise that before you continue with this one, go and watch the first video of simple harmonic motion, and then watch the second one before you come to this one. Okay. Let me also appeal that if you have not subscribed to this channel, click on that subscription button and then click on the bell icon to turn on the notifications so that when we post the next video, you'll be alerted. All right, welcome. In the first video, we talked about symbols we use to study this topic, and then in the second video, we listed the formulas we use to solve or to handle the topic. Then let me also say that mostly what we do here in physics is calculations. Where the students have issues, and then technical areas of each topic we can explain, or we are supposed to explain. We also touch theories. Like in this simple harmonic motion now, I will do a quick rundown of the terms we use in studying them. Okay. First of all, let me do a quick description of this. The word simple harmonic motion means the periodic motion of a body such that the acceleration is proportional to the displacement. Okay. The word periodic means repeated. Something that is repeated is said to be periodic. Now let me give you examples. If you know a simple pendulum, that one that goes to and fro, okay, that's an example. A bouncing ball is an example. A vibrating string is an example. Okay, a seesaw, that one that you children used to play, is an example. Do you understand? So, and so on and so forth. So you can jot these things down. Then very quickly, I want to talk about the terms we use in discussing this topic. Okay, I want to talk about the word cycle. That's the first thing I want to talk about. I want to quickly take a rundown, then we can do some calculations. A cycle is the complete to and fro movement of a body. Let's assume a ball that bounces. When a ball bounces down and up, that is one cycle. That one cycle, you can call it one oscillation, you can call it one vibration, you can call it one revolution. So it must go down and come up, you see, before you call one cycle. If it is a pendulum that goes like this, it must go to and fro before you have one cycle. Is it clear? That's number one. So cycle is complete to and fro movement of a body that is performing simple harmonic motion. Okay. Now number two, very quickly, I will explain frequency. Frequency, you can jot it down. Frequency is the number of cycles completed by a body performing simple harmonic motion in 1 second. So you can jot it down. Then number three is period. Period is the time it takes a body that is performing simple harmonic motion to complete one cycle. Okay? The time it takes a body performing simple harmonic motion to complete one cycle. Then four, amplitude. Amplitude is the maximum displacement of a medium, the maximum displacement of a body performing simple harmonic motion. Now let me assume you throw a ball to the ground. When the ball lands on the ground, it will revolt, it will rebound, and then go up. the highest height to which it can get when it rebounds is what we call amplitude. Is it clear? For a simple pendulum, as it is oscillating like this, the highest height it can get is called amplitude. Are we good? So please take note of these things. Then number 5, let's talk about angular distance. Angular distance. You can jot it down. I just want to quickly take a rundown of the whole thing. Angular distance is the distance or is the angle turned through by a body performing simple harmonic motion. Okay, so jot it down and then you can read on it. Okay, then number 6. What's our number 6? Angular velocity. You can also call it angular speed. It means the angle or the angular distance covered by a body performing simple harmonic motion in 1 second, or you can say per unit time. Then we now have 7. Okay, let me bring up resonance. Resonance. Now, look at the meaning of resonance. Resonance is a phenomenon which occurs when the forcing frequency of an external periodic force, or when the frequency of an external periodic force coincides with the frequency of an oscillating body. Let me take it again. Resonance is a phenomenon which occurs when the frequency of an external periodic force coincides with the natural frequency of an oscillating body. Let me give you an example of that. Like if you have this swing that students use, that children use to play. So as the swing is going like this and this, you can, if you allow it to be oscillating, you can decide to be pushing it as it's coming. You push it as it's coming. You are pushing it. That one you are trying to establish what we call resonance. But take the definition the way I've explained it, okay? Because this is not my major focus. I want to go to the calculation, but I want you to have a rundown of the definitions, okay? Now the next one is, let us look at let's look at number 8. Let's look at damped oscillation. Damped oscillation. Then we'll look at that. And also at the same time, we'll look at free oscillation. Okay. Now I will explain damped oscillation. I will explain free oscillation. Now, damped oscillation. If you set a ball to vibrate, to bounce, the ball will bounce on its own, and then as it's bouncing, the height of the rebounding continues decreasing until the ball will now return to the ground finally. Am I correct? Now, to a simple pendulum, a simple pendulum is like when you get a stone, tie it to the end of a rope, then you suspend this ball and allow it to begin to do like this. Are we together? So if you allow the stone to oscillate on its own, at a point the stone will be reducing in the amplitude and until it comes to rest. That's what we call damped oscillation. So damped oscillation is the oscillation of a body such that the amplitude decreases with time until it finally comes to rest. Take note of that. Then what is free oscillation? Free oscillation is a condition in which an oscillating body continues to oscillate with a constant amplitude. Take note. Constant amplitude is what? Free oscillation. That means the thing doesn't come to rest. Okay, so if it is damped oscillation, it comes to rest. But if it is free oscillation, it doesn't come to rest. Okay, so please take note of these definitions. Then finally, I want to show you guys something. Then we just do 1 or 2 calculations. Then in the next video, we complete it. Okay. Now, let me quickly talk about the simple pendulum. Look at the simple pendulum. Now, from the diagram, the simple pendulum oscillates like this. Okay? Now, it means that at this point, the pendulum is at rest. And at this point, it's at rest. And at this point, it is at maximum velocity or speed. So, at this point here, it has what we call maximum potential energy. And also here we have, it has maximum potential energy. Are you with me? Because it's at rest. You remember that potential energy is the energy of a body at rest. Now, but here also the kinetic energy is equal to 0. And also here the kinetic energy is equal to 0. Then here is in motion. It is in motion. So the kinetic energy is maximum and the potential energy is 0. I'm just giving you guys key points. Just copy them down and then learn them very well. Okay? Now, one more thing I will give you before we start our calculations is number 11. Let me do this. Let's assume that we have balls, pendulums hanging on a platform like this. Okay, let me put one more pendulum. I can put this one. I can put something like this. This one is very small. So here is A, B, C, D, and what? E. So if you look at this thing now, A and C have equal lengths. Are we together? Now, because A and C have equal lengths, resonance occurs only between A and C because of equal lengths. So take note of that. So resonance occurs between what and what? A and C. What's the reason? Because they are of equal lengths. Take note of that. Okay. So now I will quickly start the calculation process. Then I want to think that in the next video we'll be able to finish up the calculations, and but if it doesn't finish the next video, we'll still make another one. But let's just take one calculation on this topic. So let's assume calculations. Let's go this way. Number 1. A body of mass 6 kg moving around a circular path completes 20 cycles in 10 minutes. Of course, anywhere you see minutes, you have to change it to seconds, but we will talk about that. So minutes. Now the question we are going to solve now is if the radius of the path is, let us take the radius to be 15 centimeters, or let me use 35 centimeters. Calculate the A, angular distance, B, angular velocity, C, linear velocity, D, what do we take as D now? Okay, let's take centripetal force. Okay, let me clean here. Then E, let us use let's solve for frequency and F finally, period. Let's just use this to round off this particular section before we move to the next one. So please copy it down. Let's solve. Now, solution. It says a body of mass 6 kg. So what it means is that the mass is 6 kg. Check the symbol I gave you in video 1 of this series. Mass is m. Moving around the circular path completes 20 cycles. Cycles is number of cycles is n. So you write it as n. You can check your 20 cycles. You can check your table that I gave in video 1 to know what n stands for. Okay. Now in 10 minutes, 10 minutes means that the time is 10 minutes. So you have time is 10 minutes. Multiply it by 60. You change it to seconds. So it will be 600 seconds. Are we together? Now, the answer is if the radius of the path is 35 cm, radius is 35 cm. Anywhere you see cm, take note of this. Change it to meter under this topic by dividing it by 100. So 35 over 100 gives us 0.35 meter. Then we are solving for all these ones and the rest of them. So let's begin. Let's quickly solve them. Then we round this one off. Okay, so solution. Number 1, we are looking for what? Angular distance. What is the symbol of angular distance? Check that what you symbol I gave you in video 1. That's theta. Question mark means we are solving for it. So the formula is theta is equal to 2 pi n. Check formula 1 that I gave you in the second video, although I believe you have copied it down. So let's substitute. So theta will be 2 pi times n. N is what? 20. You substitute. So theta will now be, this time this is 40 pi. Unit of theta is radian. Check your table. Unit of theta is what? Radian or rad. I know you may want to ask me, why not expand this pi? Yes, if you like, you leave it in terms of pi. If you don't want to solve in terms of pi, you can do it like this. Or theta is equal to 2 times pi. Pi is 3.142. What is n? 20. So if you now solve that, you have 2 times 142. If you multiply all these ones, you are going to have 2 times this is what? That's for this time this is 6.284. Then multiplied by 20, right? So the answer will now be 0. Then we're going to have 8. We're going to have 6. We're going to have 5, and we're going to have 12 radians. Is it clear now? So please take note of that. So the B part of the question, we are looking for angular velocity. What symbol of angular velocity? W. So use this formula for it. You can use W is equal to theta over T. Okay, so you know we already have our answer for theta. And our answer for theta is 40 pi. So let me use 40 pi over time. What's our time? 600. Our time is 600. So we now have, so 0 here, 0 here. You can cancel out 2 here is 2, 2 here is okay, 4 here is 1, 4 here is 15. So the answer is your W is going to be pi over 15. You now put the unit of W, radians per second. Take note of that. If you like, you can use 3.140 divided by 15 and get your answer. You must not, it's not a must to cancel. You can just do 40 times pi divided by 600, you get your answer. Is it clear? Then the next one is linear velocity. Linear velocity, check it, that's question C, is V. So the formula that has V, you can use V is equal to W R. I gave it to you one of the formulas. Check. So V will now be what? W is what? Pi over 15 multiplied by R is 0.35 over 1. So that will be, this time this is 0.35 pi over what? 15. So if you have a calculator, you can do this by, you can divide this by this and get your answer straight. Okay. So now we have meters per second. So use your calculator, do this times pi divided by this. Your pi is 3.142. Divide it to get your answer. Is it clear? Now, what next are we solving for now? The D part says we should solve for centripetal force. What's the formula for centripetal force? Centripetal force is mv squared over r. You have it in your note. I've given it to you in video 1. So that will now give us, what's our mass? 6 kg. What's our V now? So the answer you get for this your V now, you put it here. So let me say you have 0.35 pi divided by 15 all squared. Then all over r. Our r is 0.35. So use your calculator, press out 6 times 0.35 squared times pi is 3.142 squared all over 15. Okay, so let me do it like this. There's 0.35 here times 15 squared. So this 15 squared is coming down to join this one here. I'm only, if you have a calculator, do it direct, so it doesn't disturb you. So now you as a physics student, finish this up. Use your calculator, type all this, bring it down, type this one, bring it down, then divide it to get your final answer. It's a very simple calculation. Okay. Now the E question is frequency. What's formula for frequency? N over T. So you now have N is what? 20. T is 600. So if you cancel out this over this, that's 1 over 30. That is 0.033 hertz. Unit of frequency is hertz. Take note. Then finally, period. What's formula for period? Period is T, which is equal to, period is T, capital T. Check your table. So T will be, use T over N. So now T will be, small t is 600, N is 20, 600 over 20 is 30 seconds. Alright, so this is just an introduction of the calculations for simple harmonic motion. I will, in the next video, we are now going to solve the main calculations under this. So don't miss that video. Click on the subscribe button and then click on that notification bell so that when we post the next video now, you'll be notified. We are going to the main calculations under this topic in the next video. Okay, so thank you for coming around for this video. I'll see you in the next video.